Hey guys, this is Logs Day 5. This is the last video for the week. So for today's lesson, we are going to find the inverse of our logs and our exponentials. So we're going to start with our exponentials and we're going to find the inverse, and then we'll do some problems with logs. So finding an inverse, remember you're just switching your x and your y, and then you're solving for y. So the first thing that we do is we switch our x and y. So instead of this being a y, now it's going to be an x. So I've got x equals 2 to the y. Okay, so the only way to get this out of the exponent is for us to turn this into a log. So at this point, we have to change this into a log just like we did on day 1. So first thing, identify the base. And I know this looks a little different than what we were doing before, but remember your base is always the number that has the exponent. So here my base is 2. Okay, so this is my base. And then I take those other two numbers and I swap them. Okay, so now I have a log. My base is 2. The 2 was with the y, so now it needs to be with the x. And then the y goes on the other side. And then for your final answer, you just want to rewrite it so that your y is first, or we can use our function notation and we can say the inverse of f of x. And remember, it's that like little -1 as an exponent there, but that's right as inverse of f of x equals log base 2 of x. Okay, so there's our first example. Remember, every time you're finding the inverse, switch your x and your y. Then because of the way that this is written, you're going to have to change it into a log and then just rewrite it. Okay, so we're going to do one that's a little more difficult. That's an exponential still. Okay, so here's example 2. It's going to be y equals 3 to the x plus 1. So we have something in the exponent there. Okay, actually, we're going to call this, instead of y, we'll call it g of x. Because remember, I can call the function whatever I want to. I can call it f of x. I can call it g of x. I can call it h or k of x. Doesn't matter. So this is my function. And remember, g of x or f of x, whatever it is, that is just a y. So then I can rewrite it. Y equals 3 to the x plus 1. Okay, so now I'm going to switch my x and y. So I've got x equals 3 to the y plus 1. Okay, and again, because the variable, the y value is up in this exponent, I'm going to have to switch it to a log. So whenever we switch it to a log, we first need to find the base. So my base here is 3. So I've got log base 3. And then remember, you switch those other two numbers. This y and this 1, they are all in the exponent. So this is considered like one group of things when I swap it. So I'm not just swapping the x and the y here. I'm swapping the exponent with whatever it is equal to. Okay, so the 3 was with the y plus 1. Now it's going to be with the x. So I've got log base 3 of x equals y plus 1. Okay, so I just rewrote it. So from this step to this step, I'm just rewriting it from an exponential into a log. Now from here, I need to get y by itself. So I've got this plus 1 hanging out that I need to get rid of. So I'm just going to subtract 1 from both sides. I can't combine this with the log, so I'm just going to write it next to it. So log base 3 of x minus 1 equals y. And then our final step is just write it in our function notation. So my function is called g of x here. So I'm going to call it g inverse of x, where I have that little -1 exponent equals, and then I'm just rewriting this. So log base 3 of x minus 1. Okay, so again, if you are starting with an exponential and you're trying to find the inverse, first thing, switch x and y, change it into a log, and then solve it for y. Okay, now we're going to go to question number 3. And now we're going to go into starting with a log and finding the inverse. So we're going to start with natural log of x. Okay, so again, first thing all the time when you are finding an inverse is switch the x and the y. So I've got x equals natural log of y. Okay, again, this y is like not being multiplied by the natural log. You're taking a natural log of y. Okay, so I can't just like divide by the natural log on both sides. This is like a function here that I'm taking of y. So to get rid of this, we have to switch it into an exponential. So again, when you are switching, you need to make sure that you identify the base first. So here they don't really have a base written, but if you remember from day one, the base of the natural log is an e. So e is my base here. So now I'm writing it as an exponential. So I take my base, which is e, I swap the x and the y. So the e was with the y. Now the e is going to have an exponent of x equals y. And you can rewrite it, and you can say y equals e to the x, or you can say the inverse of f of x equals e to the x. Okay, any one of those ways that you write it is totally fine. But remember, switch x and y, change it into the other form, and then solve it. For this one, it was already solved. Okay, so now this is going to be the most complex one that we've done so far. So we've got, we'll say, f of x equals log of x minus 2 plus 3. So first thing, change f of x into a y so that we can then switch them. Sorry, guys. And then I'm going to switch my x and my y. So now I have x equals log of y minus 2 plus 3. Okay, so we're trying to solve these for y. So your rules of solving are still the same. So we want to get rid of this 3 first. So I want to subtract it. I'm going to subtract 3 from both sides. Okay, now I have just a log on this side, and I've got it equal to something over here. And we can even put parentheses around these. These are one thing together. So again, once you get it to this step, you have to switch it into its opposite form. So we have a log, we want to change it into an exponential. So first we're going to find the base. So remember from day one, the base of a log is 10. Okay, so there is my base. Then I swap the other two things. So because there are multiple things in these parentheses, I am swapping the whole set of parentheses with the other. So my base is 10. The 10 was with the y minus 2, but now it's going to be with the x minus 3. So that's going to be my exponent here. So I've got 10 to the x minus 3 equals y minus 2. Okay, and we are almost done here. I just have to get the y by itself. So to get it by itself, I have to add the 2 to both sides. So I'm going to add 2 to both sides. I can't combine this 2 with the 10 or the 3, so I'm just going to rewrite it next to it. So I've got 10 to the x minus 3 plus 2 equals y. And then final step here is just write it as an inverse. So I have the inverse of f of x equals 10 to the x minus 3 plus 2. And there's your final answer. Okay, so running through the steps one last time. When you are finding an inverse, you are switching x and y. Then you are switching to the other form. So if you're starting with an exponential, you're switching to a log. If you're starting with a log, you are switching it to an exponential. Then you are just solving to get y by itself. So switch x and y, swap the form, and then solve for y. Okay, so you guys have made it through the week. Make sure you finish up your homework for the week, and then you're submitting everything to Edsby. And I will see you guys next week.